Frequency shift keying is a frequency modulation scheme in which digital information is transmitted through discrete frequency changes of a carrier signal. FSK transmitted digital information by switching a carrier between discrete information. Number of discrete frequency can be put into two categories: binary FSK, which is used two discrete frequency, and M-ary FSK, which use more than two discrete frequency.
Binary frequency shift keying (BFSK). BFSK or 2FSK uses two frequencies. The mark is correspond to logical 1 and the space is correspond to logical 0. By convention, the mark is always the higher of the two frequency. The distance between these two carriers and the nominal center frequency is called the deviation. This is also called shift, which is where frequency shift keying get his name. Note also, in BFSK, the bit rate equals the baud rate in other words, and it called symbol interval. We can transmit either a 0 or 1, that is 1 bit. Looking at the time domain representation of FSK, we can clearly see the amplitude of the carrier does not change. This is significant advantage in that it simplifies amplifier design and selection. We can recover the information even if a non-linear amplifier causes amplitude fluctuation in the transmitted or received signal. We can also make a distinction between so-called coherent and non-coherent FSK. If our to be FSK tones are generated by the same oscillator, this is called coherent or continuous FSK. On the other hand, if they are generated by separate oscillators, this is called non-coherent or discontinuous FSK. In the case of non-coherent FSK, the lack of common oscillator can be produced phase discontinuities at the switching points. This can be problematic since the sharp changes in phase can lead to issues like wider signal bandwidth or bit errors. Non-coherent FSK is, however, cheaper and easier to implement. Note that there are numerous variants of coherent FSK such as minimum shift keying and Gaussian minimum shift keying. The advantage of these two variants is they allow closer spacing of the two tones. Okay, let's look at question of tone spacing and little more bit detail. An important question in FSK is how far apart to the mark in space B. More precisely, what value of deviation we use. If the two tones is too close together, they could interface with each other, something called intersymbol interference. If they too far apart, this is spectrally inefficient, that is, signal uses too much bandwidth. So good place to start will be explaining how we can compute the bandwidth of an FSK signal.
FSK that uses more than two frequencies is called M-ary FSK. It is sometimes referred to MFSK. The number of tones or the order is always even. So we have 4 FSK, 6 FSK, 8 FSK, and etc. Each of these tones or frequencies then represents log 2 M bits. For example, in an 8 FSK system, each tone represents log 28, which is equal to 3 bits. Most of the BFSK formula in this presentation can be easily adapted to apply to the more generic case of M-ary FSK. The minimum FSK bandwidth is actually a function of both of the frequencies deviation and the bitrate signals. The formula for FSK bandwidth is 2 times the sum of the deviation and the bit rate. Let's use box-set paging for example. In this application, the 3 common bit rates are 512, 1200 or 2400 bit per second, and the typical deviation is 4.5 kHz. If we compute the minimum bandwidth for each of these data, we can clearly see that minimum bandwidth increases as the bitrate increases. M-Array FSK has been used in radio communication system for decades. One early example for the 1960 was Piccolo, which came in 6 FSK and 12 FSK variants. On the other hand, Automatic Link Establishment or ALE used 8 FSK. In addition, many modern digital two-way radio use technologies like P25, TMR, and NXDN, which are all based on 4 FSK. And also, one of the main reasons for using FSK and its application is simplicity and robustness. Using higher order M-Array FSK simply enable produce a better true output.
The FSK modulator block diagram comprises of 2 oscillators with a clock and the input binary sequence. The 2 oscillators produce a higher and a lower frequency signals which are connected to a switch along with an internal clock. To avoid the abrupt phase discontinuities of the output waveform during the transmission of a message, a clock is applied to both the oscillators internally.
Now we will proceed to a simulation part. We construct this frequency shifting circuit using IC LM555CM and transistor PNP. From this transistor, we connect the base to a function generator, the power supply, the emitter to power supply, and the collector to IC. We use 5 resistors and 2 capacitors, 1 function generator to set the frequency, and one oscilloscope to generate a signal. This oscilloscope, for channel A we connect to the IC and channel B we connect to function generator. Okay, now we will set the frequency at 50 Hz and see the signal. Okay, this lower part is a digital signal for channel A and B is the yellow one. This is a carrier signal. Okay, to get the FSK, for FSK we will combine these 2 signals. Okay, so the higher part, this is 1 and the lower part is 0. We can see the 0 for digital signal, the gap is too close, and for 1 the gap for digital signal is bigger. So from this we know that this is 101010. Next we will change the frequency to 100 Hz and the amplitude is still same, 5 dB, and run. Okay, now we can see the graph is smaller than the 50 volt and the 50 Hz. Okay, this graph is smaller, so when we change the frequency, we change the value of FC, the signal output of the signal output. So that's why so this part is frequency varying, amplitude constant. As a conclusion, we can see the higher the frequency, the smaller the wave. If frequency is lower, the wave for FS, the wave is bigger. So that's all for simulation part.
Summary of FSK. FSK conveys digital data by shifting a carrier between two or more discrete frequencies. In coherent phase FSK, there is a smooth transition between states. Minimum bandwidth and spacing of carriers often determined by bit rate. FSK widely used in many applications nowadays. That's all from us. Thank you.